Okay, so last time we talked about how to add and subtract matrices together. Now we're learning about how to multiply two matrices together. And the way we do this is by the rows and columns method. So what we do is we're going to multiply the row of the first matrix by the column of the second matrix. And here's what I mean by this. If I wanted to multiply these two matrices together, I'm going to take the element in the first row here, so R1, and I'm going to multiply it to the element in the first column here in my second matrix, which is C1. I'm then going to add it to now my second element in this row, R2, times the second element in this column, which is C2. And I'm going to keep doing this for however many elements are in each row and column. So there could be, in theory, an infinite number here till I get to the end, which would be Rn times Cn. So the answer to this problem would be row 1 times column 1. The element in row 1 times the element in column 1 plus the element in row 2 times the element in column 2 plus, and I could keep that pattern going until I get to the very end. It's worth noting that for us to be able to multiply matrices together, and this is going to sound really weird with the way I'm writing it, this matrix here is one row by n number of columns, however many elements I have here. So this would be a 1 by n matrix. This matrix here has n number of rows, however many rows we have here. It's n by, there's only one column. In order to multiply matrices together, these two middle numbers here and here must be the same number. They must be the same number. If they are not the same number, we cannot multiply them. Let's take a look at it in practice. Let's say I have R equals the matrix 3, negative 4, 5. So I have the matrix 3, negative 4, 5, and I'm multiplying that to the matrix 2, 6, negative 4. So I'm multiplying this to the matrix 2, 6, and negative 4. What I do first, the very first thing I do here, is I'm going to write the size of these matrices underneath them. So this is one row by 3 columns, so this is a 1 by 3. This here is 3 rows by 1 column, so this is a 3 by 1. Since these two numbers match, I can multiply them. If these two numbers here, the 3 there and the 3 there, did not match, I would stop right there. So to multiply these matrices together, what I'm going to do is I'm going to do the first element in the row here, so 3. I'm going to take this 3 here, which is 3 times, and I'm going to take the first element in this column here, which is 2. So the pattern I'm following is I'm following this first matrix, I'm following its rows. This first matrix, I'm following its columns. So I'm doing 3 times 2. Oops, did not mean to delete that 2. One sec. How do I undo that? Okay, well, let's undo it this way. I have 3 times 2 plus, and now we go to the next element in this first row. This first row had negative 4, so I'm going to go negative 4 times the second element in this column, which is 6. This third element here is 5, so I'm going to go plus 5 times this third element in this column is negative 4. So to get this, I'm going to do 3 times 2 is 6. Negative 4 times 6 is negative 24. And 5 times 4 is negative 20. So that means I'm getting an answer of what would be negative 20, negative 44 plus 6. I'm getting negative 38. 6 minus 44. Yeah, negative 38. And so that would be the answer. Technically speaking, this negative 38 would be a matrix. It's actually the matrix of just negative 38. The reason I know that is to multiply these matrices together, these two numbers on the inside have to match. Your final answer will be a matrix of the size of these two numbers on the outside. So my final answer here is technically a 1 by 1 matrix of negative 38. Let's try another one. Let's say I gave you the matrix A, which is 3, 1, 2, negative 1, 1, 0, and B, which is 2, 0, 1, 1, 3, 2. And I want to multiply A times B. So I'm going to take my matrix A, which is 3, 1, 2, negative 1, 1, 0. And I'm going to multiply that to matrix B. and matrix B is the matrix 2. So the first thing I'm going to ask myself is, can I even multiply these together? This is 2 rows by 3 columns, so this is a 2 by 3. And this here is 3 rows by 2 columns, so this is a 3 by 2. So the answer is yes, I can, because these two numbers here in the middle match. The final answer, I'm going to leave myself a lot of space here, but the final answer I'm going to get is specifically going to be a 2 by 2 matrix. The reason I know that is these two numbers that are left over are 2 and 2. Okay, so this is the first time we're getting something that's not a 1 by 1, so let's talk it through really carefully. I'm telling you we're going to get a 2 by 2, and I'm leaving a lot of room here on purpose. So I'm going to take the rows from the first matrix, and I'm going to take the columns from the second. So if I want the element that goes right here, the element that's going to go in the top left-hand corner, I'm going to take the first row from my row matrix, and I'm going to take the first column from my column matrix. I'm going to take the first row from my row matrix, and I'm going to take the first column from my column matrix. So I'm going to get 3 times 2 plus, and now I'm going to keep going in this row, 1 times, and I'm going to keep going in this column, 1 plus, and I'm going to keep going. I have 2 in this row matrix, so I have plus 2 times this value here of 3. All of this is going to give me a number, and that number is going to end up going here. Let me make a little bit more room. So we're definitely going to need more room here. That works out out there. So all of this is ending up in my top left value. If I want the value that's here, the value that goes in the bottom left, that, if we think of it, is truly, it's still in the first column, but it's in the second row if I want the value that goes down here. So I'm going to now use my second row and multiply it to my first column. So I'm going to go -1 times 2 plus 1 times 1 plus 0 times 3. So I'm still using my first column, but I'm using my second row because this value here is in the second row, first column. If I want this value here in the upper right, I'm now going to use my first row, because this is in the first row again, but I'm going to use my second column. So I'm going to use, my first row was 3, 1, 2, so it's going to be 3 times, and now I'm going to go to my second column. The first value in my second column is 0, so it's going to be 3 times 0 plus, and now I'll keep going. The second value in my first row is 1 times the second value in my second column was also 1 plus, and now the third value in my first row was 2 times the third value in my second column was also 2. And lastly, I'm going to continue the same pattern but for down here. So this last number is in the second row and the second column. So that means I'm going to go to the second row and the second column. I'm going to get -1 times 0 plus 1 times 1, 0 times 2. Well, you know the deal. We can't leave the numbers like this, right? We should probably actually work it out and see what we get here. So we can plug these numbers into a calculator. 3 times 2 is 6, plus 2 times 3 is 6, so that's 12, plus 1 is 13. This first value here is going to give us 13. This one here, 3 times 0 goes away. 2 times, what was that? That was 2 times 2, so that's 4, plus 1 is 5, so that's a 5 up here. -2 plus 1 is -1, plus 0, who cares? I'm getting -1. And I have -1 times 0 is whatever, plus 1 times, I'm getting a 1 here. So my final answer is the matrix C, 13, 5, -1, 1. Okay, so that was a lot. Now here's the interesting idea though. That was A times B. What if I did B times A? Everything we've ever learned in math class up to this point has taught us that A times B should be the same thing as B times A. But with matrices, that's not necessarily the case. With matrices, B times A is not necessarily the same thing as A times B. And here's what I mean by that. We know matrix B is the matrix 2, 0, 1, 1, 3, 2. So I know my matrix B is the matrix 2, 0, 1, 1, 3, 2. And I'm multiplying that to my matrix A, which is the matrix 3, 1, 2, negative 1, 1, 0, negative 1, 1, 0. The first thing I'm going to ask myself is, can I multiply these? So matrix B is a 3 by 2 matrix. It has 3 rows by 2 columns. Matrix A here is a 2 by 3 matrix. It has 2 rows and 3 columns. Since these numbers are the same, I absolutely can multiply them. My final answer, however, is going to now be a 3 by 3 matrix. Our final answer here, and I'm going to leave myself lots of room on this, is a 3 by 3 matrix. See, before we got a 2 by 2 matrix, but now I'm getting a 3 by 3. So the same pattern still holds. I'm going to use my first matrix here for rows. I'm going to use my second matrix here for columns. If I want the value here in the upper left, keeping in mind that this is supposed to be a 3 by 3 matrix, there's going to be 9 different numbers that go in this thing. So the value that goes in the upper left, that's in the first row and the first column. So I'm going to go to the first row for my row matrix, and I'm going to go to the first column in my column matrix. So I do 2 times 3, first row, first column, plus, I'm going to continue that first row, it was 0 times negative 1. That's the value that's going to go in the upper left, the first row, first column. If I want the next one, if I want this value that goes right there, if I want the value right after that, it's still in the first row, but now it's in the second column. So I'm going to go 2 times, let me see here, 2 times, and I'm going to go to the second column because I'm going first row, second column. 2 times 1 plus 0 times 1. Continue the pattern. It's going to, if I go to the third column, if I go to the, I'm still in the first row, but now third column, it's going to be 2 times, I'm now going to go to my third column, 2, plus 0 times 0. And so all 3 of these are going to give me 3 separate numbers. That's all the values for the first row. Now I'm going to move down to the second row. If I want what goes here in the second row, first column, I'm going to go to the second row, first column. So I'm going to go 1 times 3 plus, so I do 1 times 3 plus 1 times negative 1 plus 1 times negative 1. Now I'm going to move to the second row, second column. So I'm going to use the second row, second column. I have 1 times 1 plus 1 times 1. The third row, second column, is going to be 3 times 2 plus 2 times 0. And now I'm moving on to the third row. So I'm going to go third row, first column. So my third row is 3, 2. My first column is 3, negative 1. This is going to be 3 times 3 plus 2 times negative 1. Next one is going to be 3, my third row, second column. So that's going to be 3 times 1 plus 2 times 1. And last but not least, I'm going to go to the third row in the third column. That's going to be 3 times 2 plus 2 times 0. And so this is all the arithmetic we have for this. Now we need to simplify all of these. Now we need to actually do all the multiplication and adding. So I'm going to be getting a 3 by 3 matrix. I'm going to hopefully have enough space for this. 2 times 3 is 6 plus 0 times whatever is still 6. 2 times 1 is 2 plus 0 times whatever is still 2. 2 times 2 is 4 plus 0 times who cares is still 0. So I'm getting 4. 1 times 3 is 3 plus negative 1 times 1 is negative 1. I'm getting 2. 1 times 1 is 1 plus 1 times 1 is 1. I'm getting 1 plus 1 is 2. 3 times 2 is 6 plus 2 times 0 is whatever. So I'm getting 6. 3 times 3 is 9 plus 2 times negative 1 is negative 2. I'm getting 7 for down here. 3 times 1 is 3, plus 2 times 1 is 2, 3 plus 2 is 5. And last but not least, 3 times 2 is 6, plus 2 times 0 is 0, so 6 plus 0 is 6. So this is my final 3 by 3 matrix. And the really interesting thing to note about this is this and this are not equal. What this means is A times B is not the same thing as B times A. So that means for matrix multiplication, the order we multiply in matters. So I'm going to stop there. I hope this makes sense. Please give it a couple watch throughs. Understanding this pattern of multiplying rows by columns is really important for what we're going to do next.